Hi, in this video, I'll go through a complete answer to a hypothesis test of two independent means question. Previously, I already made a video showing a complete answer to a confidence interval question using an example of a one proportion question. You can click on the link up here for that video. And in that video, I introduced the steps in doing inferential statistics in an intro class. And they consist of a preparation step plus 4. In this video, I'm following the exact same steps. Step 0, preparation. Read carefully. What info is given? What is the question asking for? Step 1, restate. Restate both the information given and what the question is asking for using the correct sample or population notation. Step 2, conditions. List and check them. Step 3, compute using technology. Step 4, conclude in context. Write the conclusion verbally and in context. It's easiest to just repeat most of the question prompt. Specifically for hypothesis testing, I'm going to add some details in step 0 and step 1. In step 0, I'm adding what kind of inferential statistics is this? Is it proportions, means, chi-square, ANOVA? What? And in step 1, I'm adding write the null and alternative hypotheses. Most stats teachers teach the same 4 steps, 1, 2, 3, 4. They just call it by different names. And they don't include step 0 because they take it for granted. They take for granted that the student would be reading the question carefully. I'm just writing it out expressly. Now, one popular version for steps 1 through 4 is state, plan, do, conclude for 1, 2, 3, 4. It's equivalent to my 4 steps, but I name mine this way because I think it's more descriptive of what it is you should be doing. Let's take this example. A test to assess logical skills was given to random samples of students at 2 high schools, Hamilton and Burr. 91 students from Hamilton scored a mean of 50.1 points with standard deviation 15.3 points. At Burr, 109 students scored a mean of 53.9 points with standard deviation of 18.1 points. Is there statistically significant evidence that students at Hamilton scored lower on the logic test than students at Burr? Use alpha equals 0.05. All right, let's go through the steps. Step 0, read carefully. First sentence, it says random samples. Sounds like 2 separate samples, one from Hamilton and the second from Burr. Whatever comes next, I know it's not paired data because the populations are independent with 2 independent samples. Second sentence, look at all these numbers. Let's write them down. Hamilton, little n equals 91, x bar equals 50.1, S equals 15.3. I know it's little n, x bar, and S instead of big N, mu, and sigma, because we're talking about a random sample of students from Hamilton. So I know I should be using sample notation. Next sentence, at Burr, little n equals 109, x bar equals to 53.9, S equals 18.1. Now the question prompt. It asks, is there statistically significant evidence? That sounds like hypothesis testing. Testing that students at Hamilton scored lower on the logic test than students at Burr, meaning the first group scored lower than the second group. So maybe I'll add a subscript to these. These are 1 and these are 2. If someone does not know inferential statistics, how would they answer the question? They would say, of course, the average at Hamilton is 50.1 and at Burr is 53.9. It's the difference of almost 4 points. Of course, Hamilton scored lower. First of all, they're wrong. That's not how we look for statistical significance. But on the other hand, they do have a good intuition here. To compare the scores, we look at the averages, the means, and we compare them by subtracting and get the difference of the means. That intuition tells us this question compares 2 means. It's a hypothesis test of 2 independent means or the difference of 2 independent means. Hypothesis test needs a significance level, needs an alpha. Here it is in the last sentence. That's our step 0. Now, step 1, restate. The information given, I already had it up there, so let me go get it and copy and paste. What is asked is to compare 2 independent means. Now I write my null and alternative hypotheses. In order to do that, first I write the claim and its complement. I'll use the same indexes here, 1 for Hamilton and 2 for Burr. The claim is that the mean at Hamilton is less than at Burr. So it's mu1 less than mu2. I subtract mu2 both sides. I get mu1 minus mu2 is less than 0. That's the claim. Now it's complement. The complement of less than is greater than or equal. Now the null hypothesis H0. H0 substitute the equal sign into the claim or the complement. So H0 is mu1 minus mu2 equals 0. It substitutes in the equal sign for whatever relationship is there, just put the equal sign in its place. Now the alternative hypothesis. The alternative hypothesis picks from between the claim and its complement, whichever does not contain equal. The complement has or equal right there, so that's not it. I'm taking the claim. HA is mu1 minus mu2 less than 0. Done with step 1. Step 2, list and check the conditions. The conditions or assumptions for tests of 2 independent means are: number 1, independence. The data are independent within and between the 2 groups. For example, the data come from independent random samples or from a randomized experiment? Number 2 is normality. Each population should be approximately normal, or if we don't know about the populations, then each sample is large without outliers. Large is defined as n greater than or equal to 30. So I've listed the conditions. Now I'm going to check them. Independence? Yes. Each sample is random from its own high school population. Number 2, normality. Yes, we have sample size both larger than 30, and no one said anything about outliers. Note the difference between this part and that part. The first part where the list conditions, you just list it out. For the check part, you need to compare the listing, the general conditions, with specifically what's happening in this problem. If all you do is just repeat the general conditions, it does not count as checking. There are 2 conditions, they're both met, so conditions are met. Step 3, compute. Here's how you would compute the independent means test on the TI and on the Casio. On the TI is 2 t-tests, and on the Casio is test, then t, then 2s. On both calculators, when it comes to pooled question mark, choose no. Now start crunch. It's a calculation, so it's under stat. Then it's a test of means using the t distribution. So it's under t stats. And there are 2 samples. So it's under 2 sample. And now the choice is either with data or with summary. With data for 2 samples is when you're given 2 lists of all the measures. So for example, in this case, it'll be 1 list of all the scores from Hamilton High School, 91 of them, and a second list of all the scores from Burr High School, 109 of them. We don't have that, so it's not with data, it's with summary. Enter the information. This is when the summary in step 0 and step 1 come in really handy. 50.1, 15.3, 91, 53.9, 18.1, and 09. Scroll down, and you see this checkbox here for pool variances. It defaults to off, and that's equivalent to the pooled no on the TI and Casio calculators. We're going to leave it off. Further down, it's asking what we want to perform. Do we want to perform a hypothesis test, or do we want a confidence interval? We want a hypothesis test where the value on the right here is 0. And we need to change this relationship here to the same HA that we wrote down by hand earlier, and that is mu1 minus mu2 less than 0. And that's it. There are some optional information down here that you can click on if you want. If you want to see the critical value for the alpha equals 0.05, you can do that. If you want to plot the p-value, you can do that. Let's turn it on just to see. And we click compute. And here are the results. Double check by looking at the HA and make sure that looks exactly like the HA on paper. There's a negative t-stat and a negative critical t, and a p-value of 0.0546, which is larger than alpha of 0.05. There's an arrow here that shows there's some more results, so let's click on that. And we see the graph. This is the p-value graph that we turn on. T-stats is here at negative 1.609, and the p-value is 0.0546. That's this area here is the p-value. Step 3, compute. Use technology. P-value is 0.0546, which is larger than the alpha because alpha is only 0.05. When p-value is not less than 0.05, we do not reject H0. And that leads us to step 4, conclude in context. When we do not reject H0, the conclusion starts with, there is not sufficient evidence that. That what? That whatever verbal context that's equivalent to the alternative hypothesis HA. Well, HA in this case is the claim that Hamilton scored lower than Burr. Well, just write that down. Borrowing as much from the question prompt as possible. In fact, I'll even borrow the phrase statistically significant evidence. There we go, all 4 steps. Here's the summary of the steps again. Hope all of this helps. Any questions? Ask in the comments. Like, share, and subscribe for more contents. And thanks for watching. Bye.